Hey there. Ready for a deep dive into something that could totally change how we think about neural networks? We're tackling the lottery ticket hypothesis today.
Yeah, it's a fascinating one.
Okay, so what is it all about?
Basically, this paper argues that inside those massive neural networks we all wrestle with, there might be a smaller, more super efficient network kind of hiding,
Hmm.
what they call a winning ticket.
It's like finding a needle in a haystack,
Yes,
but the needle can do the job of the whole haystack.
exactly.
So how did they even discover this?
Well, they used a technique called pruning.
Okay.
Imagine you train a big network, and then you prune away the connections with the smallest weights.
So you're slimming down the network, but
Exactly.
how does that lead to a winning ticket?
Well, that's where it gets really interesting.
Okay.
After pruning, they reset the remaining connections to their initial weights, the ones they had before training.
Whoa, wait. Why go back to square one like that?
Right.
Wouldn't you lose all the learning that happened?
That's the surprising part. What they found was that this specific combination, the pruned structure, with those initial weights, often learns faster than the original network.
Hmm.
And sometimes even achieves better accuracy.
So it's not just about getting smaller, it's about those initial weights being somehow special.
Yes.
That's wild. Did this hold true for different kinds of networks?
Yeah, that's what's really compelling.
Okay.
They tested this on fully connected networks. Those are great for tasks like image recognition
Right.
and convolutional networks. Those are your go-to for things like object classification, and the principle held up.
Okay, so it seems like this lottery ticket idea isn't just a fluke.
Exactly.
But if it all hinges on those initial weights, does that mean we could just randomly initialize a small network and get the same benefits?
Well, no.
Okay.
That's where it gets even more interesting.
Okay.
When they tried that randomly initializing that winning ticket structure, the performance tanked. It was the specific pairing of the structure they discovered through pruning AND, those original weights, that made the difference.
So there's some hidden magic in those initial weights, even though they seem random at first.
Yes.
Do we have any idea why this works?
That's the big question researchers are still trying to figure out. It suggests that maybe those initial weights aren't so random after all, or that the optimization process is somehow drawn to these well-initialized subnetworks within the larger chaos.
That's a really cool thought.
Yeah.
Like there's this underlying order we haven't fully grasped yet.
Yeah.
So are we basically saying that if we could figure out how to find these winning tickets right from the start, we could revolutionize how we train networks?
Absolutely. Think about it. Faster training,
Yeah.
more efficient models.
Yeah.
Maybe even models that can solve problems we haven't cracked yet because they're too computationally expensive to train now.
This is starting to feel like we've stumbled onto a secret weapon. But I'm guessing it's not all smooth sailing. What are some of the challenges researchers are facing with this?
Well, one of the big ones is that the process they use to find these tickets, called iterative pruning, is pretty computationally heavy.
Okay.
It involves training the network multiple times, pruning, resetting, and so on. It works great for these initial studies, but scaling that up to the massive data sets and complex networks we use every day is a whole other challenge.
So it's like we have this amazing treasure map, but the terrain is still pretty treacherous.
Right.
Are there any other limitations they ran into?
Another interesting thing they found was that for really deep networks, like the ones you see with VGG or ResNet,
Okay.
they had to use a warm-up technique to get those winning tickets.
Warm up.
Yeah.
What that?
Basically, instead of starting the training with a fixed learning rate, they gradually increased it at the beginning.
Okay.
It seems like those deeper architectures need a little more finesse to reveal their hidden winning tickets.
So we're not just talking about pruning. It's about the whole training process needing to be adapted to this new understanding of how networks might be learning.
Exactly.
This is already making me rethink my entire approach to building models.
It's definitely a paradigm shift,
Yeah.
and we're just scratching the surface here.
We've covered a lot of ground already, and I know our listener out there is probably eager to hear about what this means for them in their day-to-day work.
Right.
So,
I think we've laid a good foundation.
yeah.
And in the next part, we'll delve into some real-world examples of how this lottery ticket hypothesis could change the game for programmers.
Okay, great. I'm looking forward to it.
So you know what's so fascinating about this research?
With that.
It seems very theoretical at first.
Yeah.
But once you start thinking about how it applies to the models you build every day,
Right.
that's when it gets really exciting.
Totally. I've spent hours trying to optimize models,
Yeah.
squeezing out every little bit of performance. And now we're finding out there might be this winning ticket hiding inside, potentially doing the job even better.
Right.
It's a bit humbling, honestly.
It really does change your perspective.
Yeah.
Instead of trying to fine-tune this massive, complex network,
Yeah.
what if we could just find the right winning ticket for that specific task we're trying to solve?
Yeah, I'm already picturing all the time and compute resources we could save.
Exactly.
But I'm curious, what would this look like in practice?
Okay.
Can you walk us through a concrete example?
Absolutely. Let's say you're working on a natural language processing project.
Okay.
Maybe you're building a sentiment analysis model to classify movie reviews.
Okay.
You got a huge data set. And traditionally, you might start by building a really complex network to handle all the nuances of language.
Yeah, lots of layers, tons of connections,
Right.
trying to capture all the complexities of human emotion.
Right. But with this lottery ticket hypothesis in mind,
Okay.
you wouldn't just focus on optimizing that whole behemoth. Instead, you'd try to uncover the smaller, specialized subnetwork within it, the winning ticket specifically for sentiment analysis.
Okay, so I train the big network, prune away the weaker connections, and reset the remaining ones to their initial values.
Right.
But how do I know if I've actually found the winning ticket?
You put it to the test.
Okay.
You compare its performance to the original network on a separate test set of reviews.
Gotcha.
Can it achieve the same or even better accuracy?
Yeah.
And can it do it in fewer training iterations?
So it's about finding that sweet spot, like a streamlined model.
Yes.
That's both accurate and efficient.
Right. And this has huge implications for real-world applications.
Yeah.
Think about deploying models on devices with limited resources, like smartphones or embedded systems.
So instead of trying to cram a massive power-hungry model onto a tiny device,
Right.
you could deploy a super efficient winning ticket that's perfectly suited for that specific task.
Exactly. And of course, we can't forget about the time and energy savings. Training those huge models can take days, even weeks,
Yeah.
and consume a ton of energy.
Right.
Imagine the impact if we could consistently find and train these smaller, faster winning tickets.
It's not just about making our lives as programmers easier.
Right.
It's about making AI more sustainable and accessible.
Exactly.
But let's be realistic for a moment.
Okay.
This research is still pretty new.
Yes.
What are some of the biggest hurdles we need to overcome before this becomes mainstream?
You're right. There are definitely challenges.
Yeah.
One of the biggest ones is that finding these tickets can be computationally expensive.
Okay.
Remember that iterative pruning process we talked about?
Yeah.
Training, pruning, resetting, repeating. It's not exactly a quick and easy solution.
Right.
Especially when you're dealing with massive data sets.
So we need more efficient methods to identify these winning tickets.
Exactly.
Maybe by analyzing how the network behaves during training or coming up with smarter pruning strategies.
Right. We need techniques that can quickly pinpoint those promising subnetworks. Yeah.
Without having to train the entire network multiple times.
Okay.
And remember, pruning itself is still an active area of research.
Uh-huh.
Right now, the focus is mostly on finding the smallest possible subnetworks,
Okay.
even if they're a bit messy and difficult to implement efficiently.
So it's not just about trimming the fat.
Right.
It's about shaping those winning tickets into something that's both lean and elegant.
Perfect analogy.
Yeah.
We need pruning techniques that create structured subnetworks.
Yeah.
Ideally, ones that align well with existing hardware and software.
Okay.
Maybe pruning entire groups of neurons or layers instead of individual connections.
It's like finding the right level of abstraction, right?
Yes.
Too fine-grained, and you end up with a tangled mess.
Yeah,
Too coarse, and you might miss those subtle interactions that make the network work.
exactly. And, of course, we need to push beyond these image-based tasks and explore the lottery ticket hypothesis in other domains.
Okay.
Natural language processing, time series analysis. There's so much potential out there. Yeah, this makes me wonder if there are some universal principles at play here.
Yeah.
Are winning tickets just a fundamental aspect of how neural networks learn, no matter what kind of data they're trained on? Are there different types of tickets for different kinds of problems?
Now those are the million-dollar questions.
Yeah.
And the answers could have a profound impact on how we design, train, and even understand neural networks in the future.
Wow.
It might even change how we think about intelligence itself.
Okay, now you're getting me really excited.
Yeah.
But before we get carried away, let's bring it back down to earth for a second.
Okay.
We've talked about the challenges, but what about the potential payoffs?
Yeah.
If researchers can crack the code on those efficient pruning methods
Yeah.
and apply this to all sorts of different domains.
Yeah.
What could this mean for the future of machine learning?
The possibilities are truly immense, but I think we've given our listener plenty to chew on for now.
I agree. Our programmer out there is probably already brainstorming how to apply all this to their projects.
Sorry that. But let's hold off on those wild predictions for just a little bit longer.
Okay.
We'll be back soon for the final part of this deep dive,
Right.
where we'll explore some of those mind-blowing implications and what this all means for the future of AI.
Okay, so we're back.
Yay.
And ready to explore the really big picture, the future of AI.
Yeah.
We've dug into the details of this lottery ticket hypothesis,
Right.
the potential it has to change how we build and train neural networks.
Right.
But now let's let our imaginations run wild for a bit.
Okay.
What are the implications if this research really takes off?
Well, one thought that keeps coming back to me is how this could change our understanding of intelligence itself, both artificial and biological.
Whoa, are you saying that these winning tickets in neural networks could shed light on how our own D-Win brains learn?
It's definitely a possibility worth exploring.
Okay.
Our brains are incredibly complex.
Yeah.
Billions of neurons, trillions of connections.
Mm-hmm.
But what if, just like these artificial networks, there are specific subnetworks that are crucial for certain tasks?
So you're saying our brains might have their own winning tickets?
Yeah.
Specialized circuits for things like language, recognizing faces, even composing music?
It's not as crazy as it sounds.
Okay.
Think about it from an evolutionary perspective.
Okay.
Efficiency is key.
Right.
Why build a massive, energy-hungry brain if a smaller, more specialized one can do the job just as well?
So if we can figure out how these winning tickets form in artificial systems, maybe we can work backward and gain a deeper understanding of how our own brains develop and learn.
Exactly. It could be a two-way street, with insights from neuroscience feeding back into the design of even more efficient and robust AI systems.
So we're talking about a future where AI research and brain research are completely intertwined.
Absolutely.
Each one pushing the other forward.
Yeah, and that could lead to some incredible breakthroughs.
Like what?
Imagine being able to diagnose learning disabilities early on by identifying missing or underdeveloped winning tickets in a child's brain. Or imagine personalized learning programs that target specific neural pathways, making education more effective and engaging.
It's like personalized medicine, but for the brain.
Exactly.
Tailoring interventions to the unique wiring of each individual.
And of course, we can't ignore the philosophical implications here.
Okay.
If intelligence can arise from a relatively small, well-organized network, what does that tell us about consciousness? Could we create conscious AI by replicating these winning ticket structures?
Okay, now we're getting into some deep philosophical waters. Those are the questions that make this field so fascinating, aren't they?
It's the ultimate quest, right? To understand the nature of intelligence itself.
Yeah.
And the lottery ticket hypothesis might just be a key that unlocks a whole new level of understanding.
So we've got this amazing convergence of AI, neuroscience, and philosophy happening.
Yeah.
But let's bring it back down to earth for a moment.
Okay.
How might this research impact the way we actually build and use AI in the near future?
Well, one of the most impactful areas could be in democratizing access to AI.
Okay.
Right now, training those massive models requires enormous computational resources.
Yeah.
It's basically an exclusive club that only big companies and research labs can afford to join.
So it creates a huge barrier to entry for smaller players.
Right. But if we can figure out how to efficiently find and train these winning tickets, we can dramatically lower that barrier.
Okay.
Imagine small startups or individual developers being able to build state-of-the-art AI systems on their laptops.
That would be a game changer.
Yeah.
It would unleash a wave of innovation with AI being used to solve all sorts of problems in every industry imaginable.
Well, exactly. And don't forget about the potential for truly personalized AI.
Okay.
Imagine having a personal assistant that's not just smart, but also incredibly efficient, running seamlessly on your phone or even a wearable device.
So AI that's not just powerful, but also perfectly tailored to our individual needs and preferences.
Right.
Almost like an extension of our own minds.
That's the vision. And the lottery ticket hypothesis might just be the key to making that vision a reality.
It's exciting and a little bit daunting to think about all the possibilities.
Yeah.
It feels like we're standing on the edge of a major shift in both technology and society.
I agree.
We're still in the early stages,
Yeah.
but the potential is Truly mind-boggling.
It
It's
is.
an incredible time to be working in this field.
Yeah.
Who knows what breakthroughs are just around the corner?
Well, dear listener, we hope this deep dive has sparked your curiosity and maybe even a little bit of awe.
Yeah,
The lottery ticket hypothesis isn't just about making neural networks smaller and faster.
right.
It's about challenging our assumptions about how intelligence works and what the future of AI might hold.
Keep an eye on this research. It just might change the world as we know it. And as always, stay curious and keep exploring. We'll see you next time for another deep dive into the fascinating world of cutting-edge tech.